Your next thought might already be written in the stars. This is the startling possibility hidden within causality, the unbreakable chain of cause and effect that dictates our reality. We are about to explore the profound idea that the future is not an open book, but a fixed narrative, and by the end of this journey, you will see the very fabric of time and choice in an entirely new light. We will venture from the bizarre rules of the quantum world to the timeless puzzles of philosophy, asking if the universe operates like a cosmic script. How much of your life feels truly your own? Aristotle gazed at the world and saw not chaos, but a cascade of reasons. He proposed that for anything to exist or occur, from a marble statue to a falling raindrop, 4 distinct causes had to align. There was the material cause, the stone itself; the formal cause, the shape of the statue in the sculptor's mind; the efficient cause, the chisel strikes that carved it; and finally, the final cause, the purpose for which it was made. This framework was one of humanity's first great attempts to map the unbreakable chain of cause and effect, a chain that links every moment in a seamless sequence. This idea was later refined into the principle of sufficient reason, a powerful assertion that nothing happens without a reason. Nothing is simply so. It implies a universe of perfect logic, where if you could somehow know the position and state of every single particle, you could, in principle, trace the entire future of the cosmos. This deterministic vision found its ultimate expression in the work of Isaac Newton. His laws of motion were so precise, so powerful, that they suggested a clockwork universe. The motion of planets, the arc of a cannonball, the swing of a pendulum, all of it seemed calculable. If you knew the present state of a system with perfect accuracy, the future was not a mystery, it was merely an equation waiting to be solved. This chain of causality is not just an abstract philosophy, it weaves through the fabric of your daily life. Consider the decision to leave your home just 5 minutes early. That simple choice, itself caused by a prior reason, might mean you avoid a traffic accident that would have occurred had you been on your normal schedule. That accident you avoided then ripples outward, preserving countless other chains of events that would have been irrevocably broken. It feels like chance, like luck, but from the viewpoint of strict causality, it was simply the inevitable outcome of a long and intricate sequence of prior causes. This presents a profound and personal puzzle. If every action is the direct and unavoidable effect of a prior cause, a link in a chain stretching back to the dawn of time, then where does your own free will truly reside? Are your choices your own, or are you merely reading lines from a cosmic script written eons ago? That moment of standing before an ice cream counter, contemplating vanilla or chocolate, feels like the purest expression of free will. It is a choice that seems to emerge from the very core of your being, a conscious decision made in the present moment. Yet, what if that feeling is a beautiful, convincing illusion? In the late 20th century, neuroscientist Benjamin Libet conducted a series of now famous experiments that cast a long shadow over this intuitive sense of agency. He asked participants to make a simple, spontaneous decision, like moving a finger, while he monitored their brain activity. The results were startling. Libet discovered a specific readiness potential, a surge of electrical activity in the brain that appeared a few hundred milliseconds before the person was consciously aware of making the decision to move. The unconscious machinery of the brain seemed to set a choice in motion before the conscious self even got the memo. This suggests our conscious mind might not be the author of our actions, but rather the narrator, telling a story about decisions that have already been made behind the scenes. This illusion extends far beyond a laboratory finger tap. Our daily choices are constantly shaped by a hidden landscape of cognitive biases and environmental triggers we scarcely notice. The music playing in a store can subconsciously influence which wine you select. The order in which options are presented can sway your final pick. You might choose a career path influenced by a teacher's encouraging comment from a decade ago, a cause whose effect only now becomes visible. Each choice feels free, but it is woven from threads of prior experience and external influence, a product of the causal chain, not an escape from it. Thinkers like Sam Harris build a powerful argument from this neurological and psychological evidence. They propose that free will is not just scientifically questionable, but logically impossible. You did not choose your genes, your upbringing, or the myriad environmental factors that shaped your brain. You cannot, in any real sense, author the next thought that pops into your head before you think it. The feeling of weighing options is itself the product of prior brain states, which were the product of states before them. If we could account for every variable, every prior cause, the choice you believe you are making would be the only one possible. This perspective forces a difficult question about moral responsibility. If no one is truly the original author of their actions, can anyone be fundamentally blamed or praised? It reframes the criminal not as a purely evil free agent, but as a disastrous confluence of genetics and environment, a link in a causal chain. It challenges our very sense of self, leading us to wonder if the conscious I is merely a passenger in the machine of the body, observing a destiny that was always written. This exploration of the mind reveals that the loopholes in causality are not just philosophical abstractions, but may be woven into the fundamental physics of our universe. The deterministic vision of the mind finds a perfect mirror in the clockwork cosmos of classical physics. In 1814, the French scholar Pierre-Simon Laplace articulated a thought experiment of breathtaking audacity. He proposed the existence of a vast intellect, a being often called Laplace's demon, that could know the precise position and momentum of every single atom and particle in the universe at one specific moment. Armed with this perfect snapshot of the present and the unerring laws of Newtonian mechanics, this demon could calculate every future state of the cosmos with absolute certainty. From the trajectory of a comet to the fall of a leaf, the entire future would be an open book, a sequence of events already contained within the present moment. This was the ultimate expression of a deterministic universe, a realm that ran with the predictable precision of a giant, unfailing machine. We see this predictability all around us in the macroscopic world. The orbits of planets are not random wanderings, they are magnificent clockwork, their positions calculable centuries in advance. When you release an apple from your hand, its path to the ground is not a matter of chance, it is a direct and inevitable consequence of gravity. There is no ambiguity, no maybe. For 19th century science, this was a profoundly empowering idea. It suggested a cosmos governed by knowable laws, a universe that was fundamentally rational and predictable. This belief in a deterministic framework fueled incredible scientific progress from engineering to thermodynamics. Yet, this entire magnificent vision rests on one impossible assumption: perfect knowledge. We, as limited human observers, can never know the exact state of every particle. Our measurements are always approximations, our observations inherently flawed. This is the first subtle loophole in the chain of causality, not a flaw in the laws themselves, but a fundamental limitation in the observer. It is this crack of uncertainty that would soon be pried wide open, leading us into the bizarre and counterintuitive realm where the very idea of a predictable future begins to dissolve. This elegant clockwork universe, however, conceals a profound strangeness at its heart. The first major crack in the foundation of determinism appeared with the double slit experiment, a deceptively simple test that reveals a bizarre truth about reality. When you fire a stream of tiny particles like electrons at a barrier with two slits, you would expect each particle to pass through one slit or the other and create two distinct bands on a detector screen behind it. But that is not what happens. Instead, the particles create an interference pattern, a series of multiple stripes, as if each individual electron traveled through both slits at once like a wave. Even more strangely, if you place a detector to observe which slit each electron actually goes through, the interference pattern vanishes and you get the two simple bands. The very act of measurement forces the particle to pick a single, definite path, collapsing its wave-like possibilities into a single point. This single experiment shatters the classical idea of a predictable trajectory, suggesting that at the quantum level, particles do not have defined paths until we look at them. This inherent fuzziness is formalized by Werner Heisenberg's uncertainty principle. This cornerstone of quantum mechanics states a fundamental limit to knowledge. It is impossible to know both the exact position and the exact momentum of a particle at the same time. The more precisely you pin down one, the more the other becomes a blur of probability. This is not a limitation of our measuring tools, it is a built-in feature of the universe itself. The particle does not possess a secret, precise position and momentum that we are too clumsy to find. The properties themselves are genuinely undefined until a measurement intervenes. This injects a seed of true randomness into the very fabric of the cosmos, a randomness that cannot be erased by better technology or more careful calculation. This leads to the mind-bending concept of quantum superposition. Before it is observed, a particle like an electron does not exist in a single state, in a single location. It exists in a ghostly cloud of all possible states and locations at once, described by a mathematical entity called a wave function. The future of that particle is not a single, predetermined line, but a vast landscape of probabilities. It is only at the moment of observation that this wave function collapses, and a single, concrete reality snaps into existence from the fog of maybe. To make this abstract idea tangible, physicist Erwin Schrödinger proposed his famous cat thought experiment. A cat is placed in a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the Geiger counter triggers and breaks the vial, killing the cat. According to quantum rules, the radioactive atom enters a superposition. It is both decayed and not decayed until someone looks inside the box. This implies the cat itself is suspended in a blur of being both alive and dead simultaneously, a clearly absurd situation that highlights how quantum events challenge our everyday understanding of cause and effect. Physicists have proposed different interpretations to make sense of this quantum weirdness. The Copenhagen Interpretation, championed by Niels Bohr, embraces this indeterminacy. It states that the act of measurement is what creates reality, and that probabilities are the ultimate truth, with no deeper, hidden clockwork beneath. In stark contrast, the many worlds interpretation suggests that the wave function never collapses. Instead, every possible outcome of a quantum event actually occurs, but in a newly branching parallel universe. In one world, you see the cat alive, in another, you see it dead. Both realities are equally real, splitting off from each other at every quantum juncture, creating a multiverse of infinite possibilities. So, does this quantum fuzziness definitively prove the future is open? Not everyone was convinced. The unsettling possibility remained that this randomness was merely a mask, that hidden variables, forces, or properties we cannot yet see were still pulling the strings from behind the curtain, preserving a secret determinism after all. Einstein found the probabilistic nature of quantum mechanics deeply unsettling. He could not accept a universe built on chance, famously objecting that God does not play dice with the cosmos. He and others proposed a compelling alternative: hidden variables. Perhaps the seeming randomness was just an illusion, a sign of our ignorance. Maybe there were deeper, unseen properties governing each particle's behavior, a hidden clockwork that would restore perfect determinism if only we could see it. This was a search for a more comfortable, classical order beneath the quantum weirdness. The question remained purely philosophical for decades, an untestable debate about the nature of reality itself. Then, in 1964, physicist John Bell found a way to force the universe to answer. He devised a brilliant theorem, a mathematical inequality that placed a strict limit on how correlated the properties of two separated particles could be if local hidden variables were real. Local here is the crucial word, meaning any hidden influence would have to travel between the particles at or below the speed of light, respecting the cosmic speed limit. Quantum mechanics, with its strange prediction of entanglement, boldly predicted that pairs of particles could violate Bell's inequality. They could be connected in a way that was far more correlated than any local, hidden mechanism could possibly explain. The gauntlet was thrown. For the theory to be tested, scientists needed to create entangled particles, separate them by a great distance, and then measure their properties in a way that left no time for a light-speed signal to pass between them. In the early 1980s, Alain Aspect and his team in France performed a series of landmark experiments that did exactly this. The results were clear and decisive. Bell's inequality was violated. The particles were correlated in a way that defied any explanation relying on local hidden variables. This was a monumental discovery. It meant that the connection between entangled particles is instantaneous, a ghostly influence that acts across any distance without any detectable signal passing through the space between them. This phenomenon, known as non-locality, punches a hole right through our classical understanding of cause and effect. An action performed on one particle, like measuring its spin, immediately determines the state of its entangled partner, no matter if it is in the next room or on the other side of the galaxy. There is no local cause for the second particle's sudden change. It simply happens, linked by a connection that transcends space. This deeply challenges the very idea that causes must always precede their effects in a neat, local chain. It suggests the fabric of reality is woven with threads that connect distant events in ways that defy simple causality. This supports the view that the universe is fundamentally probabilistic, not predetermined by a hidden blueprint. The future is not a single, pre-written line, but a tapestry of potentialities that snap into focus through interaction and observation. Yet, this non-locality hints at something even stranger. If 2 points in space can be connected outside of time, what does that imply for time itself? The ghostly connection of entangled particles forces us to confront a startling possibility, that time itself may not be what it seems. Einstein's theory of relativity paints a picture of reality far stranger than a simple sequence of causes and effects. In this view, time is not a flowing river carrying us from past to future, but a fourth dimension, woven together with the 3 dimensions of space into a single, unchanging fabric called spacetime. Every event, from the birth of a star to your first cup of coffee this morning, has a fixed location within this vast 4-dimensional block. In this eternalist model, the past is not gone, and the future is not unborn. They simply exist in the same way that Paris and Tokyo exist simultaneously in space. Your entire life, from your first breath to your last, is a timeless shape within this block universe, permanently inscribed. This perspective is supported by the curious symmetry of many physical laws. The equations governing everything from gravitation to quantum mechanics often work perfectly well whether time runs forward or backward. There is no fundamental arrow of time in the math itself. The laws are time-symmetric. The distinction between past and future that we feel so deeply seems to emerge not from the laws, but from something else, like the increasing disorder or entropy of the universe. Think of reality as a completed DVD. All the scenes, from the opening credits to the final moment, are already present on the disc. Our conscious experience is merely the laser of our awareness moving sequentially along the track, creating the illusion of a present moment that is moving forward. But the entire movie, including what you think of as your future, is already there, fully encoded. This has profound and perhaps unsettling philosophical implications. If the block universe is real, then your sense of a unique self, making genuine choices at every turn, is part of the movie's script. The feeling of weighing a difficult decision tomorrow is just as fixed as the memory of a choice you made yesterday. It challenges our deepest intuitions about personal identity and moral responsibility. If every action is a pre-existing part of the block, can we truly be praised for our virtues or blamed for our failures? We are left to wonder if our journey through life is one of genuine creation or simply one of discovery, unearthing a path that was always there. This static block model stands in stark opposition to our lived reality of change and flow. It presents a universe where nothing ever truly happens, it just is. So why do we experience such a powerful and persistent illusion of a moving present? The mystery of time deepens when we look for the one thing that seems to give it direction, a force that might truly break the symmetry and introduce an irreversible arrow into the cosmos. An egg shatters on the floor, and we know without a doubt that it will never spontaneously reassemble in its shell. We remember our childhood, but we do not remember tomorrow. This universal, undeniable experience is the arrow of time, the stubborn feeling that reality flows in one direction only. This directionality is not found in the fundamental laws of physics, but in a single, powerful principle that governs the behavior of complex systems, the second law of thermodynamics. This law states that entropy, a measure of disorder or randomness, always increases in an isolated system over time. A tidy room naturally becomes messy, a hot cup of coffee cools to room temperature, and a star burns its fuel and disperses its energy into the cold void. These processes are irreversible because they lead to a state of higher entropy. The entire reason we perceive a flow from cause to effect, from past to future, is because the universe as a whole is on a one-way journey from a state of incredibly low entropy to one of maximum entropy. The Big Bang was the ultimate low-entropy starting gun, a moment of unimaginable order and compact energy. Everything that has happened since, from the formation of galaxies to the beating of your heart, is a consequence of the universe seeking equilibrium, spreading that energy out and increasing its overall disorder. This cosmic gradient is what gives time its arrow and makes the future statistically different from the past. In a tiny, isolated system, you might see a temporary and rare fluctuation where entropy appears to decrease. A random gust of air might push all the scattered pages of a book into a neat stack, or the molecules in a drop of ink might momentarily coalesce. But for the entire cosmos, the probability of such a reversal is so astronomically low as to be practically impossible. This is where thought experiments like the Boltzmann brain come into play. In a universe that exists for a near eternity in a high entropy state, random fluctuations could, in theory, give rise to a self-aware brain, complete with false memories for just an instant. The unsettling implication is that it is vastly more likely for a single, disembodied consciousness to fluctuate into existence than for our entire, ordered, low-entropy universe to have come about. Yet here we are in a universe that is still remarkably structured, suggesting our past really was a unique, low-entropy state. This relentless march of entropy creates the stage upon which causality performs. It gives us the irreversible sequences that make cause and effect feel real and linear. It forges the illusion of an open future, a realm of possibilities yet to be narrowed down by the next causal step. Even if the block universe is true and all of time exists eternally, our conscious journey through it is lit by the lamp of entropy, moving from the ordered past toward the disordered future. We are swept along by this cosmic current, experiencing a narrative of change that feels genuine and full of choice. But what if we could step out of the current? What if we could manipulate the river of time itself, not just be carried by its flow? That leads to the tantalizing, paradoxical idea of time travel. The relentless flow of time, guided by entropy, seems to carve a one-way path through reality. Yet our imagination constantly rebels, dreaming of stepping outside the current and visiting the past. This dream, however, is fraught with logical nightmares. Suppose you built a time machine and journeyed back to a time before your parents were born. In a tragic accident, you cause the death of your own grandfather. This is the infamous grandfather paradox. If your grandfather dies before fathering your parent, then you could never have been born to travel back in time and cause his death in the first place. The event creates a catastrophic logical loop, a contradiction that seems to shred the very fabric of cause and effect. How can an effect, your existence, reach back and eliminate its own cause? This paradox suggests that consistent time travel to the past might be fundamentally impossible, a built-in safeguard to protect causality itself. Yet, the equations of Einstein's general relativity do not explicitly forbid it. The theory allows for the existence of wormholes, theoretical tunnels through spacetime that could connect two distant moments in time. It also permits structures known as closed time-like curves, paths through the cosmos that loop back on themselves, allowing an object to return to its own past without ever exceeding the speed of light. These are not science fiction fantasies, but serious mathematical solutions. However, every proposed time machine seems to inevitably generate these maddening causal loops. So how could the universe possibly allow for time travel without collapsing into logical chaos? One compelling answer is the Novikov self-consistency principle, proposed by physicist Igor Novikov. This principle asserts that the laws of physics simply will not permit a paradox to occur. If time travel to the past is possible, then any actions a time traveler takes must already be a part of established history. Your attempt to change the past would inevitably fail, not through some external force, but through a cascade of seemingly coincidental events that ensure your actions always lead to the history that produced you. You might travel back to save a famous leader from assassination, but your very presence would cause a distraction that leads to their death, or the gun you bring would jam at the critical moment. Your free will in the past would be an illusion, constrained to fulfill a script that has already been written. We see a playful version of this in stories like Back to the Future, where Marty McFly's actions in the past nearly erase his own existence. But under Novikov's rule, Marty could never actually create an alternate timeline. His every move would be subtly guided to ensure he still ends up being born, perhaps even causing the very events he remembers from his own childhood. This idea leads to an even stranger temporal puzzle, the Bootstrap Paradox. Imagine a time traveler who goes back to the 19th century and gives a young Beethoven a complete symphony, say his famous Fifth. Beethoven then copies it out and publishes it as his own work, becoming famous. The symphony exists, but it has no true origin. Who composed it? It was not Beethoven, and it was not the time traveler who merely brought back what was already written. The information or the object is caught in an endless loop, predestined to travel through time with no point of creation. It is a closed circle in causality, a story that writes itself. These theoretical models paint a picture of a universe that is profoundly self-consistent, where the future is not just predictable, but actively constrains the past to ensure its own existence. Time travel, rather than proving our freedom to alter destiny, might be the ultimate argument for a fixed and unchangeable timeline. Every journey to the past would simply be playing a part in a story that was always complete. This brings us to the final and perhaps most personal piece of the puzzle. If the future is already written, or if our choices are an illusion, what role does our own conscious awareness play in this grand cosmic narrative? Our conscious mind is the stage upon which the drama of time unfolds. We do not experience the world as a series of disconnected snapshots, but as a smooth and continuous flow, a river of moments blending seamlessly from one to the next. This feeling is so immediate and real that we rarely question its foundation. Yet this river is a masterful construction of the brain, a trick of perception known as the Specious Present. It is a window of awareness roughly 2 to 3 seconds wide where our brain stitches together sensory inputs, holds onto the immediate past, and anticipates the near future to create the illusion of a stable, moving now. This is why you can understand a spoken sentence or hear a melody rather than just a series of isolated, meaningless sounds. Your consciousness is not a passive recipient of time. It is an active editor, weaving a coherent story from the raw data of the universe. This profound role of the mind in shaping time was explored by the philosopher Immanuel Kant. He argued that time is not something we discover out in the world, like a rock or a tree. Instead, he proposed that time is a fundamental framework of the human mind itself, a necessary lens through which we must perceive all of our experiences. We cannot switch it off. We are compelled to see cause and effect before and after, because that is how our consciousness operates. This raises a startling possibility. If time is a construct of the mind, then what happens when the mind itself changes? In altered states of consciousness, such as deep meditation or under the influence of certain psychedelic compounds, people consistently report experiences that shatter the linear flow of time. Moments can feel like eternities. The sequence of events can become jumbled or meaningless, and a profound sense of timelessness can emerge. In these states, the usual chain of cause and effect seems to dissolve, replaced by a direct and immediate perception of reality where past, present, and future feel accessible all at once. These experiences have led to theories like the timeless mind hypothesis, which suggests that consciousness itself may not be bound by the linear arrow of time we normally experience. Perhaps our everyday awareness is just a filtered, narrow version of a deeper mind that exists in a more expansive relation to time, potentially able to access information or states that our waking self perceives as past or future. This is not about psychic powers, but about the fundamental nature of awareness. If consciousness is the ground from which the experience of time emerges, then it might possess properties that are not strictly sequential. So where does this leave our struggle between determinism and free will? If the universe is a predetermined block, but our conscious experience of moving through it is a mental construct, then our feeling of making a choice is no less real for being part of that construct. The freedom we experience might be the freedom of the narrative itself, the ongoing process of the brain interpreting and navigating a fixed path. Yet, the timeless mind hypothesis offers a more radical loophole. If consciousness can, in some way, step outside the linear chain of cause and effect, then the choices it makes might not be fully determined by prior physical causes alone. They could be influenced by a mind that is not entirely shackled to the present moment. This brings us full circle to the quantum world, where the act of observation plays such a mysterious role. The observer is conscious, and if consciousness has a non-linear relationship with time, could its very act of looking be what solidifies reality from the quantum fog? The connection is speculative but profoundly intriguing, suggesting that the final loophole in causality might not be in the stars but in the very nature of our own awareness. This strange link between mind and matter forces us to confront the quantum measurement problem, the deepest mystery in all of physics. We are left with a seemingly simple question that has no simple answer: what exactly counts as a measurement? When does the shimmering cloud of possibilities collapse into a single, solid fact? For pioneers like John von Neumann and Eugene Wigner, the answer was as unsettling as it was profound. They argued that no physical process, not a Geiger counter or a photographic plate, could truly complete the measurement. These devices are just collections of atoms that would themselves enter a superposition, both triggered and not triggered, when interacting with a quantum particle. The final collapse, they proposed, requires something beyond the physical, the conscious awareness of an observer. In this view, it is your act of seeing, of becoming consciously aware of the result, that forces the universe to pick a state. Reality, at its most fundamental level, remains fluid until a mind perceives it. This idea places consciousness at the very center of the cosmos, not as a passive bystander, but as an active participant in creation. Yet, this interpretation is deeply controversial. Many physicists find it unsatisfying, a kind of magical thinking that introduces a mysterious, non-physical element into what should be a physical process. Where do we draw the line for consciousness? Does a cat have enough awareness to collapse a wave function? What about a worm or a single-celled organism? This slippery slope, often called the Wigner's friend paradox, leads to absurdity. If Wigner is outside a lab, the entire lab, including his friend inside, remains in a superposition until he opens the door and asks for the result. But from the friend's perspective inside, the measurement already happened. Which reality is the true one? A more mainstream explanation, known as decoherence, offers a way out of this conundrum without invoking consciousness. It argues that collapse is not a magical event, but an inevitable consequence of interaction. A lone, isolated electron can happily exist in multiple states at once. But the moment it bumps into even a single photon from the environment, its delicate quantum state becomes entangled with the wider world. This interaction effectively leaks information about the particle state into the environment, destroying the superposition and making it appear as if a collapse has occurred. The particle isn't being observed by a mind. It is simply being forced to pick a state by its incessant chatter with the rest of the universe. This process is continuous and relentless, which is why we do not see superposition in our everyday, macroscopic world. Your coffee cup is firmly on the table because it is constantly interacting with trillions of air molecules and photons, pinning it decisively to a single reality. But then, experiments like the quantum eraser push the strangeness to a whole new level, challenging our understanding of time itself. In a delayed choice quantum eraser experiment, a photon is sent toward a screen in such a way that it can exhibit either wave-like or particle-like behavior. The truly bizarre part is that the experimenter can decide, after the photon has already hit the detector and seemingly made its choice, which measurement to make on a paired, entangled photon. This later decision appears to retroactively determine whether the first photon behaved as a wave or a particle in the past. It is as if a choice you make now can rewrite the history of an event that has already concluded. This does not mean you can change the past in a macroscopic sense, like preventing a war, but it does profoundly blur the line between cause and effect. The future measurement seems to reach back in time and influence the outcome of the past event. This gives the conscious observer, the one who ultimately chooses which measurement to make, a potential causal role that transcends the ordinary flow of time. If our choices in the present can define what was real in the past, then our reality is not a fixed path we are walking, but a path we are actively creating with every observation. This suggests a universe where the future is not already written, but is being written now with our conscious attention as the pen. We are not just reading the cosmic script, we are holding the pencil. Yet we must wonder if this creative power is an illusion. Are our choices to make certain measurements themselves the product of a predetermined chain? Or does the act of conscious observation represent a genuine loophole, a point where mind injects genuine novelty into the causal chain? The answer remains hidden, perhaps in the very nature of consciousness itself. The universe began not with a gentle expansion, but with a violent, unimaginable surge. In the first fleeting fractions of a second, a phenomenon known as cosmic inflation stretched the fabric of space itself faster than the speed of light, smoothing it out and setting the stage for everything to come. This was the ultimate act of cosmic programming, establishing the initial conditions of density, temperature, and geometry that would dictate the evolution of the cosmos for billions of years. The universe we see today, with its grand tapestry of galaxies and voids, was encoded in that explosive first moment. But this deterministic seeding gets even stranger when we look at the source of all structure. The magnificent web of galaxies, the very architecture of the cosmos, owes its existence to microscopic quantum fluctuations that occurred during inflation. Tiny, random ripples in the quantum field were stretched to astronomical sizes by the rapid expansion, becoming the gravitational seeds around which matter would eventually clump. The largest structures in existence were born from the smallest possible uncertainties, weaving a direct causal thread from the quantum birth of the universe to the galaxy clusters we observe today. This paints a picture of a cosmos whose entire history was potentially locked in place from the very beginning, a single, unchangeable timeline unfolding from a fixed set of starting parameters. Yet inflation theory itself opens a door to an even more expansive reality, the multiverse. The mechanism that drives inflation, most physicists agree, does not simply start and stop once. It is likely eternal, creating a frothing, bubbling meta-universe where inflation ends in some regions to create bubble universes like our own while continuing elsewhere. Each of these bubbles could have a random, different set of physical constants and laws. In one universe, gravity might be repulsive, preventing stars from ever forming. In another, the nuclear forces might be too weak to allow for stable atoms. We find ourselves in a universe with just the right rules for complexity and life, not through luck, but by necessity. This is the Anthropic Principle in action. We can only observe a universe that has the specific conditions required for observers to exist. The fundamental forces and constants were not fine-tuned for us. We are simply the outcome of a particular, life-compatible set of initial conditions drawn from an infinite cosmic lottery. Imagine reality as a vast, eternal library containing every book that could possibly be written. Some books are coherent narratives, others are gibberish. Our universe is one specific, predetermined volume on an endless shelf, and our conscious experience is the process of reading its pages in sequence from the first chapter to the last. Every event, every life, every thought is already inscribed in the text. Within this multiverse framework, the idea of branching timelines takes on a new character. It might seem that with infinite universes, every possible choice is realized somewhere, granting a kind of cosmic freedom. But for you, in your specific universe, the story is still fixed. The version of you who turned left and the version who turned right exist in separate, non-communicating volumes. Each branch is its own complete and unalterable narrative, its own predetermined book. Your journey feels like a series of choices, but from this God's eye view, it is simply the exploration of a single, immutable path. This cosmic scale reveals that the potential for a written future might be woven into the deepest laws of reality, governed by mathematical truths that are themselves timeless and unchangeable. These fundamental constants are the universe's deepest signatures. The speed of light in a vacuum is always exactly 299,792,458 meters per second, not a fraction more or less. Planck's constant dictates the precise quantum of action in the subatomic world. These are not suggestions or trends. They are ironclad rules that appear to have been set at the very beginning, the ultimate boundary conditions for causality itself. They are the unchangeable rules of the game, dictating what is possible from the first moment to the last. Because the speed of light is finite, no cause can ever produce an effect faster than that cosmic speed limit, preserving a logical order across the vastness of space. Because gravity is always attractive, matter clumps into stars and planets, creating the stable environments where complex chemistry and life can unfold. These laws do not specify every single event, like which specific star will form or which planet will develop life, but they rigidly define the entire playing field of possibilities. They are the ultimate guarantors of predictability, ensuring that apples fall and planets orbit with unwavering regularity. Yet, are these laws truly eternal and necessary? Or could they themselves be artifacts of our particular cosmic moment? Some cosmological theories speculate that what we call constants might not be constant at all. The fine structure constant, which governs the strength of electromagnetic interactions, might have been slightly different in the distant past. If true, this would mean the very rules of causality have evolved over time, that the game itself has changed its parameters. This leads to a profound philosophical divide. Are the laws of physics prescriptive, actively commanding the universe how to behave, or are they merely descriptive, our best human attempt to summarize the observed patterns of reality? If they are descriptive, then they are a map, not the territory. They tell us what always happens, but not why it must be that way. This leaves a tantalizing space for genuine novelty. Even within a fixed set of rules, a game of chess can produce an almost infinite number of unique games. The laws themselves do not determine the specific, brilliant move a grandmaster makes. They only make it possible. This is where chaos and complexity enter the stage, masking determinism with the appearance of pure chance. A double pendulum swings with motion that is completely dictated by Newton's laws, yet its path is so exquisitely sensitive to its starting position that it becomes practically unpredictable. The flap of a butterfly's wings, governed by the laws of fluid dynamics, can theoretically set in motion a chain of events that leads to a hurricane on the other side of the world weeks later. The system is deterministic in principle, but so complex that it generates what is, for all intents and purposes, true randomness. This emergent unpredictability is everywhere, from the weather to the stock market to the firing of neurons in your brain. It creates the fertile ground from which the unexpected seems to bloom, and this brings us to the ultimate wild card, human innovation. We cannot break the law of gravity, but we can understand it well enough to build an airplane that works with it. We cannot violate the laws of thermodynamics, but we can engineer a refrigerator that uses those very laws to move heat from a cold interior to a warm exterior. We are not breaking the rules, we are learning to play the game with such sophistication that we can bend the outcomes to our will. This is the birth of emergent causality, where a conscious agent, operating within the fixed laws of physics, can become a novel cause in the universe, initiating chains of events that would never have occurred without a guiding intelligence. The rules may be written, but the story we write with them might still be our own. A single bird follows only a few simple rules. Stay close to your neighbors, avoid collisions, and match their speed and direction. Yet from these minimal instructions, a murmuration of thousands weaves a breathtaking dance in the sky, a fluid, living entity that seems to possess a mind of its own. This is emergence, the profound principle where complex systems and behaviors arise from the collective interactions of simpler parts. The flock is a property of the whole, not something you could ever find by dissecting a single starling. Its swirling patterns represent a new level of reality, one that operates by its own rules and introduces a new kind of causality into the universe. This phenomenon is not confined to nature. Your brain is a vast network of neurons, each one a relatively simple cell firing or resting. Yet from their collective, intricate dance emerges your consciousness, your thoughts, your very sense of self. The mind is what the brain does, a property of the whole system that cannot be found in any single neuron. This is top-down causality in action, where the high-level phenomenon, the mind, can exert influence back down on its constituent parts. A conscious decision to move your arm, an emergent thought, sends a command that causes individual neurons to fire, which then contract specific muscles. The whole is now guiding the behavior of the parts. We see this everywhere in our daily lives. Think of a traffic jam. Each driver is an independent agent, simply trying to get to their destination. But when density reaches a critical point, a wave of braking can ripple backwards for miles, creating a standing phantom jam that exists only as a system-level property. This emergent entity, the traffic jam itself, then exerts a powerful top-down influence, causing every individual driver within it to slow down, altering their behavior for perhaps hours. The jam is both caused by the cars and is a cause of their new, constrained motion. In physics, the laws of thermodynamics emerge from the statistical behavior of countless molecules. A single air molecule bouncing around a room has no temperature or pressure. These are collective properties that only make sense for the whole gas. The second law of thermodynamics, the relentless rise of entropy, is an emergent rule born from probability. It creates a powerful, irreversible arrow of time that simply does not exist for the individual molecules governed by time's symmetric laws. A new causal relationship is born, one where the statistical whole dictates possibilities for the parts. Evolution itself is a majestic, emergent process. A gene is just a sequence of chemicals, but in the context of a population over deep time, the simple rules of mutation, selection, and reproduction give rise to the staggering complexity of the biological world. The emergent property of fitness shapes the fate of individual genes, guiding the entire system toward adaptation. So, does this allow for genuine novelty? Does emergence break the chain of strict determinism? In a sense, yes. The behavior of an emergent system is often fundamentally unpredictable, not because of quantum randomness, but because of sensitive dependence on initial conditions and the sheer complexity of interactions. While the underlying physics of each bird in a flock may be deterministic, predicting the exact shape of the murmuration 10 seconds from now is practically impossible. The system generates patterns and outcomes that are, for all intents and purposes, new and unforeseen. It suggests that the future is not just the sum of its parts, but is co-created through the dance of complexity itself. The universe may be following its simple, fundamental rules, but it is composing a symphony of limitless variation with them. Yet, a haunting question remains. Could all this stunning, unpredictable complexity merely be an elaborate illusion? Is the emergent symphony, for all its beauty, still playing from a fixed score? This suspicion leads us to one of humanity's oldest and most resilient philosophies. Long before quantum physics or relativity, humanity wrestled with the idea of a fixed destiny. Ancient Greek myths are filled with tragic heroes like Oedipus, whose life becomes a horrifying dance to avoid a prophecy that his every action only serves to fulfill. He is told he will kill his father and marry his mother, so he flees his home only to encounter and kill a stranger on the road, and later marry a widowed queen, thereby enacting the very fate he sought to escape. In these stories, even the gods themselves are often bound by the decrees of the fates, three ancient women who spun, measured, and cut the thread of each mortal life, their decision absolute and unchangeable. This cultural backdrop gave rise to a formal philosophical stance known as fatalism. It is the stark argument that certain events are going to happen no matter what we do. Our efforts are like a man running in a dream, feeling the strain of movement while remaining firmly in place. Aristotle captured this chilling logic with his sea battle paradox. He asked, is it true today that there will be a sea battle tomorrow? If it is true, then the battle must happen, and it is inevitable. If it is false, then it cannot happen, and its absence is inevitable. In either case, the future seems locked in place, and our actions today are powerless to alter what is already true about tomorrow. This philosophical thread weaves just as strongly through the tapestry of world religions. In 16th century Calvinism, the doctrine of predestination held that God, from the beginning of time, had already chosen who would be saved and who would be damned, an eternal decree that human virtue could not influence. Conversely, in Eastern traditions like Hinduism and Buddhism, the law of karma presents a different kind of cosmic ledger. While not strictly fatalistic, it suggests that our current circumstances are the predetermined effects of causes we set in motion in past lives, and our present actions will rigidly determine our future experiences. The current of your life is flowing along a channel carved by your own past deeds. This belief can offer a profound sense of comfort and order in the face of chaos. If a tragedy occurs, it can be accepted not as a random, meaningless horror, but as part of a larger, inscrutable plan or as the just settling of a karmic debt. It relieves the crushing weight of total responsibility, allowing for a kind of serene surrender to the way things are. Yet, this very comfort contains a dangerous seed, the potential for passivity. Why strive to change the world or even your own life if the outcome is already sealed? A fatalistic farmer, believing the rains will come or not regardless of his labor, might simply let his fields lie fallow and his family starve. Modern critics argue that this mindset can be a prison, stifling innovation, social progress, and the very human drive to improve our lot. It leads to a crucial question: is the scientific determinism we explored earlier, with its unbreakable chains of cause and effect, merely a new, sophisticated version of this ancient fatalism, just dressed in the language of physics rather than myth? Both seem to suggest our choices are illusions, but there might be a subtle yet vital difference. Traditional fatalism often implies a telos, a purpose or an end goal dictated by a divine will or cosmic principle. Scientific determinism, on the other hand, is purposeless. It is just a blind, mechanical grinding of the gears of physical law. One is a story written by an author, the other is a sequence of falling dominoes. For millennia, this was a debate confined to temples, libraries, and the human heart. But today, we are no longer limited to philosophical arguments. We can build machines to test the very fabric of reality. We can build machines to test the very foundations of causality itself. Particle colliders like the Large Hadron Collider are our most powerful microscopes, smashing particles together at nearly the speed of light to trace the unbroken chain of cause and effect back to the universe's first moments. We can watch one particle decay into others, or see how a specific force causes a new particle to blink into existence, meticulously mapping the deterministic rules that govern these tiny interactions. Yet, for all their power, these experiments run headlong into a fundamental wall. They can tell us the probability that a certain event will occur, but they can never predict the exact outcome for a single, individual particle collision. That specific result is veiled in genuine quantum randomness, a fundamental limit to what any experiment can ever tell us about the future. This unpredictability is not confined to the quantum world. It scales up into our everyday reality through chaos theory. A chaotic system is one that is completely deterministic in its rules, like the weather or the flow of a river, but is so exquisitely sensitive to its starting conditions that its long-term behavior becomes practically impossible to forecast. The famous butterfly effect is not just a metaphor, it is a mathematical reality. The tiny, unmeasurable air disturbance from a butterfly's wings in Brazil can, through a vast and complex cascade of amplifications, theoretically influence the formation of a tornado in Texas weeks later. Because we can never know the state of the entire atmosphere with infinite precision, we can never predict the weather beyond a week or two with absolute certainty. The chain of causality is there, but it is hidden from our view by the fog of complexity. This search for the causal chain extends inward to the human brain. Modern neuroscience uses functional magnetic resonance imaging, or fMRI, to watch the brain in action as it makes decisions. In experiments echoing the earlier work of Benjamin Libet, scientists have been able to predict a person's simple choice, such as which button to press, several seconds before the person is consciously aware of making that decision. The brain's machinery seems to be preparing for an action before the conscious self has even arrived at the decision. These findings have profound ethical implications. If our choices are initiated by unconscious neural processes, how can we hold people fully accountable for their actions in a court of law? It challenges the very foundation of our justice system, which is built on the premise of free, conscious choice. Even our grandest cosmological models face this limitation. When we simulate the evolution of the entire universe on a supercomputer, we are running a profoundly deterministic calculation. We input the laws of physics and a set of initial conditions, and the simulation generates galaxies, stars, and cosmic webs. But these simulations are only as good as our assumptions. We do not know the exact initial conditions of the Big Bang with perfect accuracy. We must make educated guesses. The entire magnificent output is contingent on those starting parameters, a reminder that we are observing the universe from within, unable to step outside and see the whole, unbroken causal web from beginning to end. All of these scientific endeavors, from particle physics to cosmology, point to the same humbling conclusion. Determinism remains an incredibly powerful and useful model of reality, but it is not a proven fact. The inherent randomness of quantum events, the unpredictable chaos of complex systems, and the fundamental limitations of our own perspective all leave a gap, a space where the debate over a fixed or open future continues to thrive. Our science gives us a magnificent map of causality, but it is a map with uncharted regions and edges that fade into mystery. This very uncertainty, however, opens the door to one of the most radical ideas in all of physics. What if the chain of causality does not only run forward? What if the future, in some strange way, reaches back and influences the past? The delayed choice quantum eraser presents a reality that feels almost like a cosmic editing room. In this experiment, a decision made in the present appears to reach back and rewrite the history of a particle that has already been measured. It is as if an editor, looking at the final scene of a film, could go back and change whether an actor walked through one door or two at the beginning. This is not science fiction. It is a robust experimental result that points toward a concept called retro-causality, the idea that effects can, in some circumstances, precede their causes. Our comfortable, linear view of time, where the past rigidly determines the future, begins to fray at the edges. One theoretical framework that embraces this head-on is the transactional interpretation of quantum mechanics. Proposed by physicist John Cramer, it suggests that quantum events are settled by a handshake across time. When a particle is emitted, it sends out a standard wave forward in time, an offer. But this wave is met by a confirmatory wave that travels backward in time from all the possible points of absorption in the future. The transaction is only completed when these forward and backward waves find a match, locking in a single, concrete reality. The particle's path is not set at the moment of emission, nor at the moment of detection, but through this timeless negotiation between past and future. To grasp this, think of trying to send a single, vital message to your past self. You write a letter with specific instructions and send it back in time. Your younger self receives it and, following the instructions, takes actions that guarantee you will eventually write and send that exact same letter. The letter has no true origin point. It is a closed loop in time, creating its own cause and effect. This is the essence of a Bootstrap Paradox, and it is a constant companion to retro-causal theories. They seem to allow for reality to write itself into existence with no beginning. So how does this solve quantum puzzles? It provides an elegant mechanism for phenomena like entanglement. Two particles become entangled because their future interactions are already communicating backward, ensuring their properties remain perfectly correlated no matter the distance. The spooky action at a distance is no longer spooky. It is just the result of a pre-established handshake that transcends our linear time. The future outcome is actively participating in its own creation. This forces a staggering reconsideration of agency and destiny. If the future can reach back and shape the past, then the timeline is not a one-way street we travel blindly. It is a two-way dialogue. The future you is, in some faint quantum sense, collaborating with the present you to solidify the reality you both inhabit. Your choices today might be subtly influenced by the needs of a future that is already reaching backward, guiding the collapse of possibilities into the single, consistent history that leads to its own existence. This does not grant you the power to change the past in a macroscopic way, but it profoundly alters the nature of the cosmic script. It is no longer a novel being read from page 1 to the end. It is a story that is being written from both the beginning and the end simultaneously, meeting in the middle to create a seamless, self-consistent whole. Your life is not just a consequence of the past, but potentially a cause of it as well. We watch an athlete push through the final, agonizing moments of a marathon. Every muscle screams for her to stop, but she presses on, driven by a goal she set for herself months ago. She crosses the finish line, and in that moment of triumph, the philosophical debate over free will feels utterly remote. Her achievement is real, her effort meaningful, regardless of the unseen chains of causality that brought her to that starting line. This is the lived reality of human agency, a force that operates powerfully within the world, whether the universe is deterministic or not. A school of thought called compatibilism offers a way to reconcile this experience with a scientific worldview. It suggests that free will and determinism are not mutually exclusive, but can coexist if we redefine what we mean by freedom. True freedom is not some magical ability to act without any prior cause, an impossible feat. Instead, it is the ability to act according to your own desires, beliefs, and character, free from external coercion. You are free when you choose vanilla ice cream because you like it, not because someone is forcing you. The fact that your desire for vanilla was shaped by your past experiences does not make the choice any less yours. You are the culmination of that entire causal history, and your actions flow from who you are. This perspective finds a stark but powerful ally in existentialist philosophy. Thinkers like Jean-Paul Sartre argued that we are condemned to be free. Even if the universe is a deterministic machine, we are thrust into existence without a pre-given purpose. We cannot not choose. Every moment through our actions and inactions, we are actively defining ourselves and creating meaning in a world that offers none by itself. Sitting on a couch and agonizing over whether you have free will is, in itself, a choice that shapes your life. Getting up and striving for a goal is another. Both are ways of writing your chapter in the cosmic story. Our daily lives are a testament to this practical agency. You set an alarm clock, believing it will influence your morning. You study for an exam, trusting that the effort will cause a better grade. You apologize for a mistake, hoping to repair a relationship. This entire framework of planning, effort, and morality only makes sense if our actions are genuine causes in the world. The outcomes are never guaranteed, as chaos and chance intervene, but the correlation between our efforts and the results is strong enough to build a life upon. This understanding can even bring a profound sense of relief. The crushing weight of total control, the idea that you are solely responsible for every twist of fate, can be a source of immense anxiety. Accepting that countless factors beyond your control shape your life can be liberating. It allows you to focus your energy on the things you can actually influence, your own responses, your efforts, and your character. It fosters compassion as you recognize that others are also navigating their own complex causal histories. So where does this leave moral responsibility? If no one is the ultimate, uncaused author of their actions, how can we hold anyone accountable? Compatibilism argues that we can, and we must. We praise and blame people based on their character, on the desires and beliefs that caused their actions. A kind person helps another because kindness is part of their character, a product of their causal history. A cruel person acts from a different set of causes. Holding them responsible is a way of reinforcing social goods and discouraging harms, a causal intervention in itself that aims to shape future character and behavior. The future may indeed be a story already written, but we are not merely readers. We are the characters living it, and our thoughts, our struggles, and our choices give the narrative its color, its emotion, and its meaning. We are co-authors, discovering the lines as we speak them, imbuing the fixed text with our own unique interpretation. This delicate balance between fate and effort leads us to a final, critical frontier, the ethical implications of believing the future is fixed. How would such a belief reshape our systems of justice, our concepts of merit, and our very understanding of a life well lived? A courtroom falls silent as the defense attorney makes an unprecedented argument. My client, she asserts, is not morally guilty. His brain, shaped by a childhood of abuse and a genetic predisposition to impulsivity, left him with no true choice. The crime was the inevitable outcome of a causal chain stretching back long before his birth. This scenario, once purely philosophical, now echoes in real courtrooms where neuroscientific evidence is presented to mitigate sentences. It forces a brutal question upon our justice system. If our actions are caused, can anyone truly deserve blame or praise? This is the ethical earthquake caused by determinism, shaking the foundations of how we judge one another. Hard determinism takes this logic to its stark conclusion. If every event is the necessary result of prior causes, then free will is an illusion and moral responsibility is a fiction. We would no more blame a hurricane for its destruction than a person for a crime. Both are simply natural phenomena playing out according to the laws of physics. The 18th century philosopher David Hume offered a more nuanced path, known today as soft determinism or compatibilism. He agreed that all events are causally determined, but argued that this does not erase the distinction between a free and an unfree action. Freedom, for Hume, is the ability to act according to your own desires and character without external constraint. When you donate to charity because you are compassionate, that is a free action, even if your compassion was shaped by your upbringing. When a robber forces you to hand over your wallet at gunpoint, that is an unfree action. Under this view, we can still hold people responsible for actions that flow from their own character, while showing leniency for those acted upon by external forces or internal pathologies they did not choose. This philosophical divide was captured in the famous debate between Hume and Immanuel Kant. Hume located morality in our shared human sentiments, our natural capacity for empathy, which exists within the causal world. Kant, however, placed morality on a pedestal beyond mere causation. He argued that for an action to have genuine moral worth, it must be done from a sense of duty, from a free will that can choose to obey a moral law, independent of all our desires and inclinations. For Kant, a deterministic universe would make morality a cruel joke. These abstract ideas have concrete, life-altering consequences. A justice system informed by hard determinism would abandon retribution, the idea of giving criminals their just deserts. Its sole focus would shift to rehabilitation, treating the criminal as a broken product of causal factors, and to protection, isolating dangerous individuals from society. We already see glimmers of this, with courts ordering therapy and addiction treatment instead of, or in addition to, prison time. In education, this perspective fosters profound empathy. A student who consistently acts out is not simply a bad kid, but a complex system responding to a history of causes, perhaps an undiagnosed learning disability, stress at home, or poor nutrition. Understanding this shifts our response from punishment to support, from blaming the child to altering the environmental causes that shape their behavior. Seeing others as the product of their causes does not mean excusing all behavior. It means understanding its roots. This deeper understanding is the very seed of compassion. It is the recognition that had you been born with that person's genes and lived their exact life, you would be them, making their same choices. This knowledge can dismantle self-righteousness and build a more humane society, one focused on fixing the causal conditions that lead to suffering and harm, rather than merely punishing the final link in the chain. The idea of a written future is not just a physicist's puzzle. It is a social and ethical challenge that asks us to redesign our institutions with wisdom and compassion. Can we use this knowledge to build a better world, one that heals its broken links instead of simply breaking them further? This philosophical journey through causality is not just an abstract exercise, it is a powerful toolkit for reshaping your own life. The same chains of cause and effect that seem to bind the cosmos can be harnessed to build better habits and achieve personal goals. Consider the simple act of forming a new routine, like a daily walk. You can engineer this outcome by manipulating its causes. You place your walking shoes right by the door, a clear visual cue. After the walk, you reward yourself with a few minutes of your favorite music. You are not relying on fleeting willpower. You are constructing a reliable causal loop where the cue triggers the action, and the reward reinforces it, making the behavior more automatic with each repetition. This is the mechanics of habit formation laid bare, a practical application of deterministic principles for personal growth. On a deeper level, cognitive behavioral therapy operates on this exact premise. It teaches you to become a detective of your own mind, tracing the chain of causality from a triggering event to an automatic negative thought, which then causes a painful emotion, which in turn leads to a self-defeating behavior. By learning to identify and challenge that initial thought, the cause, you can fundamentally alter the emotional and behavioral effects that follow. You are not a passive victim of your feelings. You are an active participant in the causal network of your own psychology, learning to reroute well-worn neural pathways. This principle extends to ambitious goal setting. A dream like running a marathon or writing a novel can feel overwhelming, a distant effect with no clear cause. But by breaking it down into a sequence of smaller causal steps, you make the future tangible. The cause of finishing a marathon is consistent weekly training. The cause of writing a novel is writing a single page each day. Each small action is a cause that builds inexorably toward the desired effect, creating a personal timeline of achievement that you actively author. We see this causal power in the mastery of any craft. A concert pianist's flawless performance is the direct effect of thousands of hours of deliberate practice. Each note practiced, each scale repeated, forged new neural connections, causing a level of skill that appears almost magical to the observer. The musician's future capability was written note by note in the practice room, a testament to how sustained effort sculpts destiny. Even in moments of stress, understanding causality grants you power. Mindfulness meditation trains you to simply observe the causes of your anxiety, a looming work deadline or a difficult conversation, without immediately reacting. This pause, this observation, creates a critical space between the cause and your response. In that space, you find a measure of freedom, the ability to choose a more skillful reaction rather than being hijacked by the automatic causal chain of fight or flight. Embracing this view fosters profound self-awareness. You begin to see your own personality, your strengths and your triggers, not as mysterious givens, but as the logical outcomes of your unique causal history. This knowledge is not meant to foster resignation, but to cultivate effectiveness. You can work with your nature, not against it, planting better causes to harvest better effects. You are learning to dance with the chains of causality, using their rhythm to move toward a life of greater intention and purpose. Yet, for all our careful planning, life remains punctuated by the unexpected, the random event that shatters our best-laid causal maps. A lottery ticket flutters from a pocket, forgotten for weeks until a news bulletin reveals its numbers have hit the jackpot. This sudden, life-altering fortune seems to arrive from nowhere, a bolt from the blue that shatters any predictable chain of events. Moments like this, both wonderful and tragic, feel like pure chance, wild cards dealt from a deck that causality cannot seem to shuffle. They are the starkest challenge to a fully written future, introducing a crack of genuine novelty into the deterministic machine. At the most fundamental level, this randomness is not an illusion. The quantum events we have explored, like the unpredictable decay of a radioactive atom, are governed by genuine probability. There is no hidden cause, no secret variable that dictates the exact moment an atom will split. This inherent randomness at the foundation of all matter means the universe is constantly rolling dice at a microscopic level, and the outcomes of those roles cascade upward, influencing everything in their path. Nowhere is this creative power of chance more magnificently displayed than in evolution. The raw material for natural selection is the random genetic mutation, a copying error in the DNA code that occurs for no reason, with no foresight. One such random change might make a beetle slightly darker, and if it lands in a soot-covered forest, that meaningless fluctuation becomes the cause of its survival and the future of its entire lineage. The breathtaking diversity of life is built upon a foundation of countless such accidents, a testament to how uncaused events can shape grand, emergent destinies. Humanity has always wrestled with this unpredictable element. Ancient Romans cast lots and read omens, seeking patterns in the chaos. The rise of probability theory in the 17th century, ironically born from gamblers analyzing dice games, gave us our first mathematical tools to tame uncertainty. We learned to quantify risk, to calculate odds, and in doing so, we built entire industries like insurance and financial markets on the explicit acknowledgement that we cannot predict individual events, only their statistical likelihood. We cope with an unwritten future by betting against its uncertainties. This leads to a deep philosophical divide. Is true randomness a fundamental feature of reality? Or is it merely a mask for our ignorance? Is the roll of a die truly random? Or is it simply the predetermined outcome of the exact force of your throw, the air resistance, and the surface it lands on, factors too complex for us to calculate in the moment? For some, this distinction is everything. True randomness offers a clean break from determinism, a door to a future that is genuinely open. The alternative, that chance is just hidden complexity, preserves the clockwork universe merely shrouded in a fog of our own limited perspective. Regardless of its ultimate nature, this element of unpredictability is the spice of life. It is the source of surprise, of wonder, and of terror. It is the reason we feel anticipation for the unknown and relief at a narrow escape. A world where every event was not only predictable but predicted would be a sterile and suffocating story, one we had already read. The flutter of that lottery ticket, the chance encounter that leads to a lifelong friendship, the unexpected mutation that saves a species from extinction, these are the moments that inject vibrancy and possibility into the cosmos. They suggest that the future is not a single, pre-inscribed line, but a vast, branching tree of potentialities, with chance acting as the wind that guides which branches grow. Yet, this very uncertainty invites a final, provocative question. If our knowledge were perfect, could we predict it all? Could a vast intelligence, armed with a complete understanding of every quantum state and every chaotic interaction, see through the veil of chance and read the final chapter of the universe? A supercomputer hums in a chilled room, its processors analyzing quintillions of data points to simulate the global atmosphere. Its weather forecast for next week is not a guess, but a staggeringly detailed probability map, a causal forecast born from modeling the physical forces that drive our climate. This is the new frontier of prediction, where artificial intelligence and machine learning are becoming the modern oracles of our age. These systems do not think, they correlate. They are trained on immense datasets, learning to identify subtle patterns and causal relationships that are invisible to the human eye. They can forecast stock market fluctuations by analyzing news sentiment and trading volumes, or predict your next online purchase by tracing the digital breadcrumbs of your browsing history. Their accuracy grows with every new piece of data, seemingly inching us closer to a predictable world. Yet these technological crystal balls have profound limitations. Their vision is only as clear as the data we feed them, and our data is often messy, incomplete, or deeply biased. A machine learning model trained on historical crime data to predict future offenses will simply learn to replicate the prejudices of the past. If a police department historically patrolled certain neighborhoods more heavily, the data will show more crime there, leading the algorithm to direct even more patrols to that same area. This creates a terrifying self-fulfilling prophecy where the prediction itself becomes the cause, perpetuating inequality under the guise of scientific objectivity. We see a similar double-edged sword in healthcare. An AI that can predict a patient's risk of a specific disease can save lives by enabling early intervention. But that same prediction, if it becomes part of a person's medical or insurance record, could also be used to deny them coverage or employment, effectively writing a tragic future for them based on a probability. The algorithm is not evil, it is just math, but its outputs can have devastating human consequences. The ultimate goal of this technological pursuit is a system of such immense intelligence that it could approach the mythical power of Laplace's demon, forecasting not just the weather, but the unfolding of human events. Yet even the most advanced AI would slam into the same fundamental barriers that protect our future from total prediction. It could never know the exact quantum state of every particle, and even if it could, the inherent randomness of quantum decay would inject noise into its calculations. It would also be defeated by chaos, where the tiniest rounding error in its model of the planet's climate could lead to a completely different forecast for next month. Perhaps the most unsettling power of predictive technology is its ability to create the very future it proclaims. When a financial algorithm predicts a market crash and investors panic sell because of that prediction, they cause the crash that was forecast. The prediction was not a glimpse of a fixed destiny. It was an active participant in the causal chain, a loud suggestion that the crowd chose to obey. We are building systems that do not just foresee our path, but that lay down the tracks ahead of us as we walk. This technological lens shows us humanity grappling with causality on a grand scale, using the most powerful tools we have ever created to peer into the fog of tomorrow. But do these tools reveal a future that is already written, or are they helping to write it themselves? To find a deeper answer, we must step away from the machines and listen to the voices of those who have spent a lifetime studying the fabric of reality. Albert Einstein famously declared his resistance to the quantum revolution with the words, "I, at any rate, am convinced that he does not throw dice." For him, the probabilistic nature of the subatomic world was a placeholder for a deeper, more complete theory that would restore a universe of perfect causality, a cosmos of elegant and definite laws. His philosophical adversary, Niels Bohr, offered a gentle but firm rebuttal, telling Einstein, "Stop telling God what to do." Bohr urged his colleague to accept that the universe was fundamentally probabilistic at its core, that this inherent fuzziness was not a flaw in our knowledge, but a feature of reality itself. This great debate between two of the 20th century's finest minds was not merely about physics. It was a clash of worldviews, a struggle over the soul of the cosmos. Today, that conversation continues with new voices and fresh perspectives. The theoretical physicist Sean Carroll eloquently defends the block universe model, the idea that past, present, and future all exist simultaneously in a timeless four-dimensional loaf. He suggests that our feeling of a flowing present is a stubborn illusion, a psychological artifact, and that free will is not the ability to change the future, but the experience of being a complex system moving through that fixed structure. On the question of free will, philosopher Daniel Dennett provides a pragmatic roadmap. He argues for a compatibilist view, where free will is perfectly real and meaningful within a deterministic framework. For Dennett, free will is not magic. It is a set of high-level capacities like the ability to reflect, to anticipate consequences, and to act in accordance with our considered desires. A chess-playing computer is not breaking the laws of physics, but it is exhibiting a form of intelligence and choice that is genuinely different from a rock rolling down a hill. The late Stephen Hawking offered a powerful insight into why this debate is so difficult to resolve, pointing to the profound connection between time's arrow and the human brain. He noted that any successful theory of the universe must account for our perception of time flowing from past to future, a perception inextricably linked to the increasing entropy that our brains, as complex computational systems, must process. Meanwhile, the renowned mathematician Roger Penrose proposes a truly radical solution to the measurement problem, speculating that the collapse of the wave function is a gravitational effect and that this process is intrinsically connected to the nature of consciousness itself. He ventures into territory where physics meets the philosophy of mind, suggesting that our awareness may play a fundamental, non-algorithmic role in the universe. This diversity of expert opinion reveals a vibrant, ongoing inquiry. At physics conferences and in philosophy journals, the nature of causality remains a live wire, a puzzle that refuses a single, neat solution. These thinkers are not just providing answers, they are enriching the questions, showing us that the loopholes in causality are not failures of understanding, but gateways to a deeper reality. Their collective wisdom serves as a guide, reminding us that the universe is strange enough to accommodate both rigid laws and genuine novelty. To truly feel the weight of these ideas, we must step beyond the equations and quotes and into the realm of pure thought, where logic alone can bend the fabric of possibility. A cat rests in a sealed box, its life hanging on the unpredictable decay of a single radioactive atom, according to the rules of quantum mechanics. Until someone opens the box and looks inside, the atom exists in a blur of both decayed and not decayed states. This means the cat, too, is suspended in a phantom realm, neither alive nor dead but both at once. This thought experiment forces us to confront the absurdity that arises when quantum weirdness scales up to our familiar world, challenging the very definition of life and reality based on causal chains we cannot see. It asks where exactly the line is drawn between a probability and a fact. Another kind of box tests the nature of mind itself. The Turing test proposes that if a machine can converse so convincingly that a human cannot distinguish it from another person, we should consider it intelligent. An advanced artificial intelligence might pass this test, its responses flowing from a complex web of algorithms and data, a perfect causal chain of input and output. But does this simulated conversation reflect genuine understanding and free will, or is it merely an intricate puppet show with its strings pulled by prior programming? The machine's choices would be the inevitable result of its code, raising the question of whether our own minds are fundamentally different or just running on wetware with more hidden variables. A much older puzzle strips choice down to its bare bones. Buridan's ass is a donkey positioned exactly halfway between two identical piles of hay. With no reason to prefer one over the other, the paradox claims the donkey, perfectly rational and devoid of any internal bias, would starve to death paralyzed by indecision. This highlights a crucial flaw in a purely deterministic view of decision-making. In reality, our choices are never made in a perfect vacuum. A random neural flicker, a subtle breeze, a fleeting memory, some tiny, unpredictable influence always breaks the symmetry, pushing us one way or the other. Our freedom may not be absolute, but it is forged in the breaking of perfect equilibrium. This leads to an even more expansive thought. The simulation hypothesis suggests that our entire universe, with all its laws and history, might be an artificial construct, a sophisticated program running on some advanced civilization's computer. If this is true, then our perceived causality is just the execution of code. The future is not written in the stars, but in the logic of a simulation, and what we experience as chance could be a seeded random number generator. Our lives would be part of a grand, predetermined narrative, and the programmers would hold the ultimate causal authority. Even the simple act of perception is riddled with mystery. The old philosophical question asks, if a tree falls in a forest and no one is around to hear it, does it make a sound? The question probes the relationship between events and observation. From a purely physical perspective, the falling tree creates air pressure waves, but the experience of a sound, the conscious perception of noise, requires an eardrum and a brain to interpret those vibrations. This echoes the quantum measurement problem, suggesting that reality might have layers, and that the full manifestation of an event might depend on a conscious observer to complete the causal circuit. These thought experiments are not mere intellectual games. They are mental gymnasiums where we stretch our understanding of cause and effect to its breaking point. They reveal that causality is not a simple, rigid chain, but a fluid and nuanced concept, changing its character from the quantum to the cosmic, from the mechanical to the conscious. By wrestling with a cat both dead and alive, a thinking machine and a starving donkey, we prepare ourselves to face the ultimate synthesis, a cohesive picture of a future that may have been complete since the very first moment. So where does this leave us in our search for a final answer? The evidence pulls us in two powerful directions. From one perspective, the universe appears as a grand, deterministic machine, its gears turning with the precision of Newton's laws and the fixed geometry of Einstein's spacetime. In this view, the future is a chapter in a book that has already been written, a path laid down in the four-dimensional block of reality. Yet, from another angle, the cosmos resembles a probabilistic garden of forking paths, where quantum randomness plants seeds of genuine novelty and chaos ensures that no map can ever perfectly predict the journey. The role of consciousness deepens the mystery, as our own awareness seems to be both a product of this causal chain and a potential author that solidifies reality from a fog of possibilities. We are left not with a single truth, but with a spectrum of interpretations. Some see a river with fixed banks, its overall course determined by the landscape of physical law, yet its waters are a turbulent, unpredictable dance of waves and eddies. The river must flow to the sea, but the exact path of each water molecule remains a story of chance and interaction. Your life, then, can be seen as a voyage down this river. The choices you make feel intensely real and weighty because you are the one experiencing the current, navigating the rapids, and feeling the spray on your face. The sensation of deciding, striving, and caring is not diminished by the possibility of a fixed banks. It is the very substance of the journey itself. This synthesis reveals that the loopholes in causality are not flaws in our understanding, but essential features of a reality complex enough to encompass both ironclad laws and open-ended potential. Science offers a magnificent map of these territories, but it cannot finally decree whether the destination was always there or is being drawn with every step we take. This unresolved question is not a failure but an invitation. It asks you to reflect on your own experience. How does this profound uncertainty shape your daily outlook? Does the idea of a deterministic universe bring you comfort in its order, or does it feel like a prison? Does a cosmos brimming with chance excite you with its freedom or fill you with anxiety? Your answer to these questions may be the most personal choice of all, a conclusion that you, as the conscious traveler, get to write for yourself. The beauty of our journey is that we do not need a final answer to live a meaningful life. Embracing the fundamental uncertainty of the cosmos can paradoxically become a profound source of peace. When we release the exhausting burden of needing to control every outcome or predict every twist of fate, we free ourselves to focus on the only moment we truly possess, the present. This is the core wisdom of ancient Stoic philosophy, which teaches us to make a clear distinction between what is within our power and what is not. We cannot control the external causes that swirl around us, the stock market, the weather, or another person's actions. But we can absolutely control our responses, our judgments, and our own efforts. This inner citadel of choice, however it is generated, is the true arena of our freedom. It is the space where we cultivate character and resilience, regardless of the script the universe may be following. Science itself thrives on this embrace of the unknown. Every great discovery begins not with an answer, but with a compelling question. The mysteries of dark energy, the origin of consciousness, the final nature of reality, these are not failures of understanding, but the very engines of exploration. They remind us that the universe is a story still being decoded, and we are privileged to be the readers, turning one page at a time. This sense of wonder is echoed in the art that moves us most deeply. Franz Kafka's stories plunge us into worlds where logic fails and causality seems absurd, reflecting our own confusion in the face of a vast, impersonal universe. An abstract painting does not tell a single, fixed story. It invites a personal interpretation, a unique collaboration between the artist's intention and the viewer's own causal history. These works celebrate ambiguity, teaching us that meaning is not always about finding the one right answer, but about the rich, personal experience of the search. This humility in the face of life's great puzzles can dissolve the walls of the self, fostering a deep sense of connection. When we recognize that everyone we meet is navigating their own complex web of causes and conditions, just as we are, judgment softens into compassion. We are all fellow travelers on a road whose final destination is hidden from view, doing our best with the maps we have. This perspective empowers a balanced life, one that honors both diligent planning and graceful surrender. We set our goals and plant our seeds with care, understanding the causal power of our actions. Yet we also learn to hold the results lightly, accepting that chance, chaos, and a million unseen variables will have their say. We become like sailors who skillfully adjust the sails to the wind, not cursing the sea for its unpredictability, but dancing with its power. This is how we live fully within the mystery, whether the future is written or we are writing it with every breath. Our human journey, then, is not about solving the cosmic riddle, but about learning to love the questions themselves. Our ancestors first stood upright on the savannah, a simple biological cause that would ripple into an unimaginable effect, freeing their hands to carry and to craft. That initial spark of innovation, the first stone tool, set in motion a causal cascade of technological adaptation. Each invention, from the controlled use of fire to the development of agriculture, was not an isolated event, but a new link in a chain of escalating complexity. Plow caused surplus food, which caused settled societies, which in turn caused writing, law, and culture. Our journey to the moon began with that first sharpened flint, a direct line of causality written across millennia. This is cultural evolution, a powerful engine where ideas themselves become potent causes. A philosophical concept born in one mind can spread, causing social revolutions. A scientific discovery in one lab can trigger technological upheavals across the globe. Our collective future is being written by this mimetic drift, the relentless competition and cooperation of ideas that shape our path. We can see this causal machinery at work in the great tipping points of history. The Industrial Revolution was not a single event, but a perfect storm of intertwined causes. The steam engine, improvements in iron production, and new agricultural techniques all converged, creating feedback loops that catapulted humanity into a new age. The causal chain of the Internet, born from military research, has now rewired global consciousness, altering how we communicate, work, and even think. These are not mere historical periods, they are causal singularities, points after which the future branches onto an entirely new trajectory. The story of humanity is a vast and intricate tapestry. Each individual life, each invention, each seemingly minor decision is a single thread. Woven together by the loom of causality, these threads create a grand, emergent pattern, the complex and beautiful narrative of our species. We cannot see the full design from our position within the weave, but we are both the material and the weavers. Now, for the first time, we are gaining the power to not just follow the pattern, but to consciously alter the loom itself. Technologies like genetic engineering allow us to reach into the causal code of life, potentially rewriting the biological scripts that have governed evolution for billions of years. Artificial intelligence presents us with a new kind of causal agent, a non-human intelligence whose decisions could reshape our economy, our society, and our very understanding of mind. With this profound power comes an even more profound responsibility. Understanding causality means recognizing that our actions today are the causes that will shape the world for generations to come. The carbon we release into the atmosphere, the genetic lines we edit, the intelligent systems we unleash, these are not isolated experiments. They are the first dominoes in a chain whose end we cannot see. We are being handed the pen that writes the cosmic script, and we must learn to write with wisdom, foresight, and a deep sense of stewardship for our planet and for each other. This grand perspective ties the personal to the cosmic. Your life, with all its choices and chances, is one vibrant thread in this immense tapestry. The future of our species, and perhaps of life itself, is the emerging pattern. We are living through a chapter where we transition from being merely characters in the story to becoming its conscious authors. The narrative is not yet finished, and the weight of the next page rests in our hands. The threads of destiny are spun across the world's great myths. In the cold halls of Norse legend, the gods themselves march toward Ragnarok, a final, cataclysmic battle they know is coming. Their struggles and preparations are not to prevent this future, but to meet it with courage, for the prophecy is unchangeable. Similarly, Hindu cosmology describes vast, repeating cycles of creation and dissolution, where the universe breathes in and out over eons, each age following a predetermined script. These are not stories of chaos, but of cosmic order, however terrifying that order may be. They reflect a deep human longing to see pattern and purpose in the tumult of existence, even if that purpose ends in fire. This narrative pattern is crystallized in the archetypal hero's journey, a template found in stories from ancient epics to modern blockbusters. In The Matrix, Neo is told he is the one, a figure prophesied to save humanity. His entire journey is a tension between this apparent destiny and the choices he makes to either accept or reject that role. Harry Potter bears a scar marking him as his world's savior, a fate sealed by a villain's choice before he could even walk. These narratives captivate us because they mirror our own internal struggle, the feeling that we are both shaped by forces beyond our control and yet must actively choose our path. The ancient Greek image of the three fates, women who spin, measure, and cut the thread of each mortal life, is perhaps the most enduring symbol of this theme. It is a chillingly beautiful idea that the length and quality of our days are woven on a celestial loom, our personal triumphs and tragedies already patterned into the tapestry. This archetype offers a strange comfort, a way to reconcile with life's unfairness and its inevitable end. Modern science fiction continues to explore this terrain, often with more nuanced tools. In the film Arrival, a linguist learns an alien language that rewires her brain to perceive time not as a linear path, but as a complete, simultaneous whole. She experiences memories of a future daughter while that child is still years away from being born. Her choices are not made in ignorance of their outcomes, but with full knowledge of the joy and heartbreak they will bring. This is not a story of escaping fate, but of embracing a known future with open eyes, finding meaning within a timeline that is already fully realized. These cultural narratives serve as a psychological playground where we can safely confront our deepest anxieties about control and meaning. They allow us to ask the terrifying question, what if my life is not truly my own, and then find a way to live with the answer, whether it offers the comfort of a plan or the caution of a trap. These stories are humanity's way of rehearsing for a reality that might be fundamentally predetermined, giving us the emotional and philosophical tools to navigate a world where the future might already be written. Yet, for all the wisdom in these ancient tales and modern parables, they are born from a place of not knowing. What happens when our tools of discovery become so powerful that they can move beyond myth and metaphor to potentially test the very fabric of destiny itself? Deep beneath the border of Switzerland and France, scientists are steering particles into collisions that recreate the universe's first trillionth of a second. At CERN, the quest for a theory of quantum gravity is not just an academic exercise. It is a direct assault on the biggest causality puzzle of all. General relativity gives us a smooth, deterministic spacetime, while quantum mechanics offers a fuzzy, probabilistic world. Unifying them could finally tell us if the fabric of reality is a continuous, causal tapestry or a pixelated screen where cause and effect can flicker on and off. Does gravity emerge from the entanglement of tiny spacetime quanta? The answer could reshape our understanding of whether the cosmos runs on a single, unbreakable clockwork or a more fluid, interconnected logic. Meanwhile, the inner universe of the human brain is yielding its own causal secrets. Researchers are now using sophisticated brain-computer interfaces to map the precise neural cascades that lead to a decision. They can watch an intention form not as a single spark, but as a sweeping storm of electrical activity across the brain's network. By stimulating specific neural patterns, they can even bias a person's choices, creating a causal link from the outside in. This research is moving beyond simple button presses to explore complex moral decisions, tracing the biological chain of events that leads to a judgment of right or wrong. It pushes us to ask, if we could map the entire causal landscape of a human brain, would we see a person's future choices laid out before they ever thought them? Our gaze also extends to the deepest reaches of space. The James Webb Space Telescope is not merely taking pretty pictures, it is a time machine peering back to the infancy of the first galaxies. By analyzing the faint light from these primordial structures, cosmologists are testing their models of how quantum fluctuations during inflation became the causal seeds for all the structure we see today. Each ancient galaxy is a fossilized piece of the early universe's causal chain, allowing us to check if the story we have written about cosmic evolution matches the evidence written in the stars. This is the ultimate historical test, comparing our theoretical causality against the universe's own recorded history. In the realm of artificial intelligence, a new frontier is emerging: causal AI. Most current machine learning is a master of correlation, spotting patterns without understanding why they exist. But the next generation of algorithms is being designed to learn causal relationships. An AI might not just see that dark clouds are associated with rain, but understand that the clouds are the cause. These systems could run digital simulations of the world, testing interventions to see their effects, building intricate models of cause and effect that could one day surpass human intuition. They could forecast not just what will happen, but what will happen if we change something, giving us a powerful new tool to navigate the future's branching paths. Philosophy is keeping pace with these scientific leaps, giving rise to new frameworks like post-determinism. This is not a return to strict fate, but a sophisticated middle ground that acknowledges the powerful constraints of physical law while making space for genuine agency and emergence. Some philosophers are revisiting the nature of time itself, proposing that it is not a fundamental property but an emergent one, a story that complex systems like us tell to make sense of a universe where all moments might be equally real. This interdisciplinary conversation is where the deepest truths will likely be found, at the crossroads of physics, neuroscience, and philosophy. We are living in an era where age-old questions are finally becoming testable. The combined force of these explorations, from the quantum to the cosmic to the computational, is converging on a single, profound target, the engine of reality itself. We are building the tools to not just wonder if the future is written, but to potentially read the first few lines for ourselves. This forward momentum ensures that the greatest story ever told, the story of why anything happens at all, is far from over. Our journey through the loopholes of causality reveals a universe of profound tension. We have navigated from the rigid clockwork of Newton and Laplace, where the future seemed a mere calculation, to the fuzzy, probabilistic core of quantum reality, where particles defy single paths until observed. We have encountered the timeless block of spacetime, where all moments may exist at once, and the irreversible arrow of entropy, which gives our lives their narrative flow. The evidence for a predetermined cosmos is formidable, a chain of cause and effect linking the birth of stars to the thoughts in our brains. Yet, this deterministic tapestry is threaded with brilliant uncertainties. Quantum randomness injects genuine novelty, chaos theory masks predictability with beautiful complexity, and the enigmatic role of consciousness suggests our observation might be the pen that writes reality into being. The human spirit has consistently demonstrated its resilience, not by demanding absolute freedom, but by seeking purpose and creating meaning within the grand narrative, whatever its nature. We build, we love, and we strive, not because the future is guaranteed to be open, but because the act of striving itself is what makes us feel alive. The cosmos may be a story already written, or it may be a story we are writing together. The incredible truth is that we are here to read it, to question it, and to find our place within its pages. As Carl Sagan so beautifully put it, somewhere, something incredible is waiting to be known. This search for understanding, this relentless curiosity in the face of the ultimate mysteries, is what defines our human experience. We invite you to continue this exploration with us. Share your own thoughts on fate and free will in the comments below, and subscribe for more journeys to the heart of space's greatest enigmas. Keep looking up and never stop wondering.